We have just some reminders. We have a general trinomial, and hopefully we can factor this. 2x and x. Oh, I need 3 somehow. 5 and 4 somehow. 5 and 4. Yeah, 8 and 5. So we have minus 4 plus 5, because that'd be a negative 8x. Positive 5x, that's going to be a negative 3x. So then we can continue on and find out what makes each of these 0. So 2x equals negative 5. Negative 5 halves, that's one of them. Set the factors equal to 0, so 0 product property. And then x minus 4, we want to know what makes that 0. And that is 4. So negative 5 halves and 4, that's the answer on this one. We have a perfect square trinomials. If it's perfect square, that means it's x plus 4, x plus 4. We can write this as x plus 4 squared. That's what the perfect square means. It means it's the same thing. It factors into the same thing. Perfect square trinomial. Now there's only one answer. Negative 4 makes that 0. We have the difference of two squares. 4x minus 3, 4x plus 3. The pattern there. The inside 0, the middle term 0. So 4x minus 3 equals 0. We can add 3. I know I'm kind of in the way. I'm trying to get out of the way. So x equals 3/4. And then we can write 4x plus 3 equals 0. 4x is going to equal negative 3. So x is equal to negative 3/4. So plus or minus 3/4. That always happens on the difference of two squares. One's going to be the plus, one's going to be the minus. And then we have a common monomial factor, which means we can take something out. We want to take the highest out. So 4, I think, is what we can take out of this. That's going to be 3x plus 5. So we can factor out a common monomial. Well, 0 makes x 0. It's almost like a trick question. It's not negative 4. 4 times negative 4 is not 0. I get that every once in a while. And then 3x plus 5 is equal to 0. 3x is equal to negative 5. So x is equal to negative 5/3. So 0, negative 5/3. There's a little review on each of the types of factoring that we've done and how you solve those. The fundamental theorem of algebra says if you have a polynomial of degree n, you have n factors. You have n solutions. This has a power of 3, this polynomial. So the number of solutions, we need 3 solutions. This is the difference of two cubes. The A is 3y. The B is 2. So I can write that as 3y to the third minus 2 to the third. There's your A and your B. Now the pattern is A minus B. So 3y minus 2. A squared, that's 9y squared. So same sign, now it's opposite sign. It's going to be 6y. We're going to take 3y times 2 in the middle. That's part of the pattern. Multiply the two together. And then we finish it with b squared. Well, we're asked to solve these now. We want the solutions because this is set equal to 0. I'm going to do this. Page width. Well, let's find this one. 3y minus 2 is equal to 0. Add 2. Divide by 3. That's the quick and easy one, in my opinion. So there's one solution. We still need 2 more. Well, this quadratic gives us the other 2. Now, the sum and difference of two squares, these they're always, they will always be imaginary. The other 2 will always be imaginary. So let's find out if that's right. We got x equals negative 6 plus or minus the square root of 36 minus 4 times 9 times 4 all over 2 times 9. Quadratic formula. Well, I need 36 minus 4 times 9 times 4. That ends up being negative 108. So there we have the imaginary. Square root of negative 108 over 18. Is that my stuff dinging over there?
Yeah.
Does it sound like? Okay, I gotta get that turned off. I need the perfect squares in 108. I think, is there a 16 in there? No. 108 divided by 4, 27. So there must be a 36 in there. 108 divided by 36, 3. 36 and 3. So 36 and 3 is 108, and 36 being the perfect square. Now this becomes negative 6 plus or minus 6i square root of 3 over 18. Square root of 36 is 6. That comes out front. It's imaginary because we're squaring a negative. That's the I. And then 3 is left inside there. And finally, all 3 of these are divisible by 6. So negative 1 plus or minus I square root of 3 over 3. There's the final answer. And plus this one over here. There's one answer, and there's 2 answers right there. One with the plus, one with the minus. We needed 3 answers. Any questions on that? Keep rolling then. Factor the polynomial completely. There should be 4 solutions on this. The highest degree, the highest power is 4. 4 solutions. Negative 36. So I need x squared and x squared. Factors of 36 that add to positive 9. Plus 12 minus 3. Plus 12 minus 3. All right? Yeah, that's plus 9. Well, neither one of those are perfect squares. We can't keep factoring as perfect squares, but we can use square roots. We can set this left one equal to 0, minus 12, square root both sides. So plus or minus square root of negative 12. There's 2 solutions. Now I have to simplify this. So we have a little bit more work to do on this when it's when there's perfect squares in there. So now we have x equals plus or minus. 12 is 4 times 3. So 2i square root of 3. And that's what I'll expect to give you full credit. If you stop short of that, you're not going to get full credit for the problem, of course. Now we have the other side. Add 3. X equals plus or minus square root of 3. And square root of 3 we can't do anything with. So we end up with 4 answers, just like we said we needed. There's 2 here, and there's 2 answers there for a total of 4. Now a couple of them are imaginary. That's okay. Number of solutions, again, this is a power of 4. This is a quartic polynomial. We need 4 answers. Whether they're real or imaginary, we need a total of 4. Yeah, we got x squared and x squared. 4 and 12, that's not it. What else? 6 and 8, that's not it. 2 and 24, I don't think this factors. Does it look like it factors? I don't think so. 3 and 16. 3 and 16, that's not 18. 2, 3, 4. 4 and 12, 5, 6 and 8. Okay, so it doesn't factor. It says factor the polynomial completely. Yeah, I know what to do not factoring. Let's see, 1, let's exhaust all possibilities. 1, 2, and 3, 4, 6 and 8, right? Yeah. And not 7, well 8. All right, so then it's 4 and 12, 3 and 16, 2 and 24, and then 1 and 48. I don't think any of those add up to 18. So, here's what we can do. We can still do let me get back to you. I'm going to ask the person that wrote this and see what they're after. We can still use the quadratic formula, but before I do that, before I show you that, I want to make sure that's what whoever wrote this, that's what they're after. So I'll get back to you on this one. Ones that don't factor, but they're to the fourth power. I'll get back to you. X to the fourth minus 16, this is the difference of two squares. So x squared minus 4, x squared plus 4 equals 0. Hold on one second, I'll be right back. I think the person who wrote it is right.
I think it was T-Shap. There's no teachers for this one. Look at the right. Look at them. I had the teacher now. You're failing. Can I look at 9?
In this class, they have a 9. It's in this, what it is.
I have a 95.
All right, I'm glad I asked.
What'd you say?
It is wrong. It should be 45. There is a way to solve this using the quadratic formula, but it's a little complicated. They could have told me that earlier. So what is it? Let's see. What we got 9 and what is it? 15 and thank you. 15 and 3. So x squared minus 15, x squared minus 3 equals 0. There we go. Neither of which are perfect squares. That's okay, because we can use square roots. We can add 15, right? X squared minus 15 is 0. Add 15. Square root. There's 2 answers, and there's no perfect squares in 15. So then we add 3 over, and we have plus or minus square root of 3. So there's your 4 answers. And why does my phone keep dinging me? All right. So let me turn all this sound down. I got all kinds of issues today. There we go. All right, now that's much better. That goes with the instructions of factoring. All right, so back to this one. Number of solutions, 4. Again, we have an x to the 4th. We notice that this is a difference of 2 squares, except it's x squared. Well, now we have another difference of 2 squares, right there. This is not the difference of 2 squares, no matter how hard you try. That one does not factor into x plus 2x minus 2, because that's x squared minus 4. You can't get a plus 4 with a pattern. But we have 2 solutions right here. We have a positive and a negative 2. That's what makes those 2 0. This one's a little bit more complicated because it's not a minus. We set that equal to 0. Minus 4, and we're going to get 2 imaginary answers. Because when we square root this, it's not plus or minus 2, it's plus or minus 2i. Square root of 4 is 2, it's negative, so it's I. 4 answers. If you don't come up with 4 answers, if you count and you only have 3, you probably didn't write plus or minus. You probably missed that. That happens all the time. What else do we have? Let's keep rolling. Number of solutions. Oh, 5 solutions this time. So there's got to be something different. And what's different is we can take a 3 out and an x out. So let's take a 3x out. That's going to be x to the 4th plus 10x squared plus 16 equals 0. Factors of 16 added to 10 is 82. We have x squared minus 8, x squared minus 2. We have our first answer, 1 of 5. 0 makes x 0. That's the first one. That 3x, 0. We have x squared minus 8 is equal to 0, so x squared is equal to 8. We add over the 8. Square root. That's plus or minus 2 square root of 2. 8 is 4 and 2. Square root of 4 is 2, so that 2 comes out. 4 comes out as a 2, but there's a 2 left on the inside. X squared minus 2 is equal to 0, so x squared is equal to 2. Add the 2 over, and the fourth and fifth answer is plus or minus square root of 2. So there's 2 answers, 4 answers. That's the fifth answer right there. So you can tell if you've done something wrong, if you've missed the plus or minus, because when you add them up, you don't have enough. If you don't have enough, you probably missed a plus or a minus. Well, the plus and minus. Number of solutions, 4. Highest power is 4, so in the end, we better come up with 4 answers. This one, we can take a 2 and an x out for sure, 2x. That's going to be x to the third plus 64. This one's going to be quite a bit of work here because we're going to have to use the quadratic formula eventually. Well, now this is the sum of 2 cubes. This is x to the third plus, it's 4 to the third. 64 is 4 to the third. Look off to the right-hand side of the board. You see a 64 up there. That's a perfect cube. The a is x, the b is 4. So here's the pattern, x plus 4. It's same sign. X squared, opposite sign. You multiply the a and the b. 4x. A is x, the b is 4. And then plus 16 equals 0. We can get 2 of them pretty quickly, I think. First of all, x is 0. That first one, that x right there. 0 makes x 0. Negative 4 makes x plus 4 0, so negative 4. Now, that was the sum of 2 cubes, and the sum of 2 cubes will always have 2 imaginary answers. The difference of 2 cubes will always have 2 imaginary. So we have x equals 4 plus or minus the square root of 16 minus 4 times 1 times 16, all over 2 times 1. (16 minus 64). 16 minus 4 times 16. Negative 48. There's your imaginary. 4 plus or minus square root of negative 48 over 2. Well, we got some simplifying to do here. That's 4 plus or minus 4i square root of 3 over 2. 48 is 16 and 3. The biggest perfect square is 16. 4's in there, that's not the biggest. So 16 and 3, square root of 16 is 4. That's on the outside. And then we have square root of 3 on the inside. All of these are divisible by 2. The final answer, at least this one over here, is 2 plus or minus 2i square root of 3. We divided everybody by 2. Now you don't divide what's in the radical by 2. So here's 1 answer, 2 answers, 4 answers right there. Is that what I needed? Yep, 4 answers. Awesome. A lot to go through today. All right, take a breather. Stretch out a little bit. Get ready to finish up here. We got a few more. This is taking a while today, but there's a lot to cover. 3 solutions. 3. This is 4 terms. Anytime you get 4 terms, it's going to be factored by grouping. We group the first 2, we group the last 2. We can take an x squared out of the first 2, x minus 2. We can take a 9 out of this, x minus 2 equals 0. Now these need to be the same. If those aren't the same, you did something wrong, you missed a sign somewhere. Those have to be the same. Well, these two, this is a pattern. We're not really multiplying or anything like that. This is a pattern. We bring the x squared plus 9 back together. And the pattern is we bring these 2 back together. Now, I've had students tell me that that should be squared. That is not correct. Those don't come back together as a square. They come back together as 1. Well, we have x squared plus 9 is equal to 0. X squared equals negative 9, so we minus the 9 over. This is all the same stuff over and over and over again. There's just different ways to get here. X is now plus or minus 3i. Square root of 9 is 3, but it's negative. It's imaginary. Then the other one, the third answer, is 2. 2 makes x minus 2, 0. Hey, oh, last one. Here we go. Last one. We got a factor by grouping again. Watch this. Here we go. Boom, right there. There's a minus in the middle. You got to change that sign so that both of the parentheses are plus. 9x squared. Okay. So 3x plus 5. There we go. And then we can take a 1 out. 3x plus 5. In other words, you really can't take anything out. But you can always take a 1 out. So if you can't take anything out, it's a 1. These two come back together, making 9x squared minus 1. These two come back together. They make 3x plus 5. I can keep factoring. 3x minus 1, 3x plus 1. That's the difference of two perfect squares. Everything up there, everything in that is a perfect square. 9, that's 3 squared. X squared is x squared. 1 is 1 squared. They're all perfect squares, and it's minus. 3x plus 5, there we go. So 3x minus 1 is equal to 0. Add 1, divide by 3. First answer, 1 of 3. Well, this one must be negative 1/3 because it's the difference of two squares. We minus 1 and we divide by 3. And then finally this one, we do something very similar except there's a 5 there. Negative 5, negative 5/3. So there are your 3 answers. That's what we needed. We needed 3 answers. Any questions? Sorry about that mix-up on the other one, but I knew something had to be off. Yeah, because it said factor and we couldn't factor it.